Hello everyone, welcome to Unit 3. I know we made it. And so this stuff might not seem very interesting at first, but it actually does give way to a bunch of different, really cool stuff in mathematics. So you have to kind of understand this, and then you could get to more other stuff. And it's not just abstract, even though some of what I say will be kind of abstract, but some of it is very real and happens all the time. And that'll be more in the second video, or the next lesson. But basically, this lesson is called two-way tables. And it's called two-way tables because here's one way, and here's the other way. It's just the two axes, right? So, this, I've used the word set in some of my other videos without actually explaining what the word means. It just means a collection of different things. And in math, that's usually numbers, right? A collection of certain numbers is called a set. And so, yeah, okay, so we have a table here, and it's actually the same exact table that's in your textbook, which is nice. But what's really helpful with these is changing things up with them mathematically, doing algebraic functions with them mathematically, because we could represent this on a graph, right? And then we could see the distribution. But when we put it in a table like this, we could do more algebraic and numeric kind of things with it. So we can compare them more. Basically, one of these sides, one of the ways is, do you have a cell phone or you do not have a cell phone? So it's a binary kind of thing. You either have it or you don't. You're either pregnant or you're not, right? And then this side is just your age in years. So here's all the 10 through 12-year-olds, 13 through 15-year-olds, 16 through 18. So let's pretend I went out on a survey and I asked a bunch of people how old they are and if they have a cell phone or not. And this is the data that I got. And I want to try to analyze this, right? So we could say, it just looks like a bunch of numbers right now. I mean, we could say that, okay, yeah, now only 8 people versus 52, don't have a cell phone versus have a cell phone when they're older, right? But we don't really see kind of what's actually happening here. So what we can do for this is convert these all to percentages. Because these are all just numbers right now, right? But if we get them in percentages, we can compare the frequencies of these a lot better than we can right now just by looking at them. So I already converted them to percentages, but just a reminder, we're converting each of these numbers as a percentage of the total people that we got, because a percentage is just a fraction of a whole, right? So each of these is going to be a fraction of however many people we surveyed. And we can figure out how many people we surveyed just by adding these all up. So when you do that, the total is 170 people. So if we want to find out the percentage of how many people have a cell phone and are also in the age group from 10 to 12, then we just divide 25 divided by 170, right? I'll just write that here. And that would be that. Okay, so I'm just going to quickly write down the percentages here. So this would be about 15, and this isn't exact at all. This would be about 20... I can't even read my own handwriting. 22%. This would be around 31%. This is about 21. I can't even draw a percent sign either. 21%. That would be 7%. And that would be, call it 5%. Okay, so now we can actually better see like a distribution of all this data, right? 15% of people were in this category, 10 through 12, and also had a cell phone. So we can see the biggest group, right, is this 31. Most people, like if we were to just pretend all of these are marbles and draw a random marble out, you would have a 31% chance of being 16 through 18 and having a cell phone. So we could also do different stuff with this data, right? We could compare it to other data. Let's say we had another survey, which is having a laptop versus not having a laptop, and see how this changes. And because this is kind of a linear kind of thing, I mean, we all age at the same rate, right? Unless, well, it's fine. While we're all on Earth, we age at the same rate. So you can see that the percentages increase of having a cell phone as you get older. And you can also see that with the numbers, right? But it goes from 15% to 22% to 31%. And correspondingly, these get smaller, right? Because if these are getting bigger, the having the cell phones, then the people who don't have the cell phones, that percentage is also going to be getting smaller. And you can also kind of see where a big jump is. I'm not actually sure how accurate. That's fine. But yeah, you can see how this jumped from 15 to 22%, and this went down from 21% to 7%. That's a huge jump. So yeah, and you could also add this whole column up, see how many people have a cell phone total, and see who doesn't total. And you could do the same thing with any of these rows, right? See the total number of 10 through 12, see the total number of 13 through 15s, all that stuff. So this is just kind of the base of different sets, different probabilities. You can kind of think of it a bit with the percentages, right? The random marbles. But this is just a really great way to numerically represent this data in a table.